Okay, so we're going to complete and balance each equation. So these are all single replacement reactions. So you have lead sulfate and copper. This was lead 2, so it's balanced there. Here we have silver plus copper nitrate. Nitrate is 1, so you need 2 of those, which means you're going to have 2 of those and 2 of those. You have copper 2 chloride plus hydrogen, so you need 2 of those. You have zinc nitrate, you need 2 of those plus lead. You have magnesium plus zinc sulfate, and you have hydrogen gas plus zinc chloride, so you need 2 of those. And then everything is balanced. The symbol of the more active element in test tube 1 is going to be the copper. The symbol less active is the lead, and so on. So number 2 is copper and silver, and number 3 is hydrogen and copper. Number 4 is zinc and lead. Number 5 is magnesium and zinc. And number 6 is zinc and hydrogen. And this will start to get you thinking that you can make your own activity series. Okay, so this is where we get down to the nitty-gritty. Of the 3 metals, lead, copper, zinc, which is the most active? Lead, copper, zinc. So you find that zinc is the most active of those 3. And of the least active, that's going to be copper, which makes sense since we use it for wiring and houses and things. Experimental evidence indicates which 3 metals is most active, which was least active. When you take a look at your test tubes, or in this case your well plates, and you see that copper was more active than lead and silver, but hydrogen was more active than copper, and zinc was more active than hydrogen, so zinc is more active than copper, and zinc was also directly more active than lead. So you could do that using test tubes 1, 3, 4, and 6. So test tubes 1, 3, 4, and 6. Arrange the metals lead, copper, zinc, silver, magnesium from least active to most active. So we had silver and copper, then so that's silver and copper, and we're left with lead and zinc and magnesium. Is hydrogen more active or less active than copper, zinc, silver, and magnesium? Copper, zinc, silver, magnesium. So it's right in the middle. So you'd say it is more active than copper and silver, but less than zinc and magnesium. Okay, so experimental evidence established location of hydrogen. So in test tube 3, you had hydrogen more active than copper. In test tube 6, you had zinc more active than hydrogen. And when you compare the test tubes 1 and 2 with test tube 3, so those are your copper placements, and then 4, 5, and 6, those are your zinc placements. That gives you an idea exactly where hydrogen are. So directly, you would say you could compare test tubes 3 and 6, and then use that evidence along with 1 and 2, and 4 and 5. What additional tests would be necessary to establish the exact position of hydrogen in the series? You would do a test. You would do a test with hydrogen and lead in the same test tube. So you compare your activity series 1 in the textbook. Well, Mr. Schuth is exactly the same. If it's different, it could be because you weren't seeing something that you were supposed to. Or perhaps you didn't clean what you're supposed to clean. So why acid is not stored in steel containers? Because hydrogen is more active than iron, which is the majority of steel, in which case it would eat away at the iron container. Sodium is a very active metal. Why is it only found in compounds in nature? Because it is already reacted and become a compound before we get to it in nature. Okay, and the last one is why magnesium metal rather than copper. So magnesium rather than copper can be used with hydrochloric acid. Well, since magnesium rather than copper is more active than hydrogen, it can be used in a single replacement reaction as it kicks out the hydrogen since it's more active. Since copper, if you did a copper plus hydrochloric acid, then you're going to have what we call no reaction. So you would not be able to use that combination.